Yo, 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 yo! Welcome to my channel. We are looking into some physics today, which the topic will be projectile motion. And as you can see here, this is one of the questions that I snatched from one of the year 11 student, year 11 physics student, and which is about projectile motion. And I think that it pretty much cover everything in the projectile motion, and that's why I decided to make a video about this particular question and solve it to show you guys how it is done. It's pretty easy, but you have to do it step by step. Okay, we have to. My method is easy. My method is simple, but I will tend to find out everything before I start to answer the question. All right, just giving you a warning. If you think that, once I got the answer for that particular question, I will stop there, up to you. But for this particular video, I'm going to solve, pretty much everything, what's happening to the object at different time frame, and then come back to the question at the end. Okay? So, at the beginning, we got a cliff, a 60-meter high cliff, right? On top of that cliff, an object was launched into the air, right? With the projectile motion into the air, at a 34.5 degree, above horizontal, and then with a speed of 88.3 meter per second. I should put the unit there. That is meter per second. 88.3 meter per second velocity. Okay, so we've got 3 questions to answer at the end. How far away from the base of the cliff will the object land? That's question 1. Second one, for how long did the object travel in the air? All right. And third one, what is the final impact of the object to the ground? Great. Let's do it. And okay, so every time when I come across a projectile motion, I will finish the drawing of it. Okay, so let's just pretend it launched in the air and time continue. Okay, so we'll go boop, 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 bee. Okay, so it will reach a peak here. So this is the peak. Oops, not with B. Peak. Right, and then boop, 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 boop. Okay, so eventually, right, it will reach a point where it is completely the same height, right, the same vertical displacement as the cliff before, but now it's just on the right. All right, so it reached this particular point, right, and then continue to fall until it hits the ground. All right, so let me just draw the ground. Try and draw it as straight as I can. Okay, and then boom, hits the ground. All right, so this is the path of the object. Okay, so right at the beginning, I would like to break things into parts. All right, so okay, let's look at when the object. I will use a different color pen. Let's look at the objects or the things happening to the object when it is traveling from this point to this point. All right, so we call that part 1. All right, okay, and then from the peak to back down here, that will be part 2. And then from this point to when it hits the ground, this will be part 3. So I will just break it down into 3 parts. And then I'm going to find out everything about these 3 parts. Or everything about the object. Alright? And by what I mean by everything, I mean the vertical component of the object, the vertical speed of the object, and the horizontal speed of the object, or horizontal velocity. Okay, so, alright, so there's a couple things you need to understand about projectile motion. Now, the projectile motion usually forms a, well, always, I should say always, they will form a parabola. And by what I mean by parabola means that it will travel, let me use another pen. So this whole bit is the parabola. Yeah, this is the parabola. And by what I mean by parabola is what I'm trying to get you guys to understand about the parabola is that the amount of time it taken for it to come to here and the amount of time it taken for it to come to here is the same. All right, let's treat this as T1, T of the part 1 and T of the part 2, right? And they should be the same, right? Given that parabola is symmetric. So this will be our midpoint here. And that's why this point is important, all right? So from the left-hand side of the midpoint to the and from the midpoint to the left-hand side and from the midpoint to the right-hand side, it should be the same. And by what I mean by same, the time you take for the object to travel from the beginning to midpoint, and then from midpoint to the end of the parabola would be the same. Okay, and other thing would be the same as well, assuming there is no air resistance, which most of you would have been told by your teachers, because at year 11, year 12 physics, I don't think in many cases we considered air resistance, so we're just ignoring that. So good. So at this point, when it come back here, it should have a same velocity, right? And then it forms the same angle, which would be 34.5. All right, just have that in your mind. Okay. All right. So before we start to do the, and we also talked about ignore air resistance. Right, we have to ignore air resistance. Okay, so therefore, the horizontal acceleration is always 0, and the horizontal velocity would never change. Okay, so just make that clear. Have that in mind. All right, let's find out the part 1. What's happening to the object at part 1 when it travel from this point? When it travel from this point to the peak. All right. So obviously our reference of frame will be at the peak. All right. So I would say at the peak. All right. So we have two sets of everything. So we have the vertical and the horizontal. Okay. This is the horizontal vertical component and horizontal component of the velocity vector. So we got uv, which is the initial horizontal initial vertical speed, vv, which is final vertical speed, vertical velocity, and then av, which is acceleration vertical acceleration, and then sv, which is the vertical displacement, right? And the last bit is t, right? And for the horizontal part, we have the same as well. So UH, and then VH, and then AH, and then SH, and last bit the T. Now, some of you would have realized by now why did I not put a little subscript on t? The reason why is because t for both of them would be the same. Well, I wouldn't put it this way. The main determining factor of the time the object travel in the air, let's put it that way, the travel will be the vertical acceleration. Since we're ignoring horizontal acceleration, since we're ignoring the air resistance, so there's no horizontal acceleration. So the object is constantly got pulled down by a vertical acceleration, which will be gravity in this case. And that will be the main determining factor of how long the object will spend in the air, right? So that's why I treat the time is the same on both. All right. Even though your horizontal velocity is not changing, but once you reach the ground, you'll be considered rolling instead of projectile motion, right? So the amount of time the object spend in the air is mainly determined by the vertical vertical acceleration, and hence there's only one set of time that we can use. Okay, hopefully you understand it that way. Well, that's how I see it. Okay. All right. So first thing first, we need to break down the initial velocity. Right. The initial velocity is at an angle. Right. The angle is 34.5 degrees. Now we need to break that velocity factor down to its component factor, which will be the horizontal component and the vertical component. All right. Let's do that. So the horizontal, let's draw the diagram first. So we've got a line here. It's 88.3 meter per second. All right, with an angle of 34.5. All right, so we're looking for this horizontal component and vertical component. Right, which would be easy. We use sine and cosine. All right. So this would be our the vertical component, and this would be our horizontal component. All right. So we know that sine 34.5 is equal to v over 88.3. Right. Opposite over hypotenuse, and then 88.3. multiplied by sine 34.5 will give us v, right? And if you put the calculation in the calculator, you get 50.01 meter per second, equal the vertical component, the vertical velocity component. All right, the next bit is just the same, so you would use cos instead. That's equal to h over 88.3, which is the adjacent over hypotenuse. So 88.3 multiplied by sine 34.5 is equal to h. And we get 72.77 approximately is equal to horizontal velocity component of the speed, of the velocity factor. All right, so let's put these two in. So the v here. Okay, no. Let's look back into the diagram. We are talking about at this point here, right, at the peak. Okay. So when the object travel from the top of the on top of the cliff to that peak, we can see we already list out everything here. So right at the beginning, the object's vertical velocity, right, the initial vertical velocity would be whatever we got here. Right, so that would be 50.01 meter per second. And final vertical velocity at the peak, right, at the peak there would be 0, because momentarily the object would have stopped increasing vertically, and then after that instant of the stop, it will start traveling down, right? So at the split second, when it's at the peak, the final vertical velocity would be 0. All right. Now, the vertical acceleration from the top of the cliff to the peak, right, will be negative because the object is traveling upward, and gravity, which the vertical acceleration, is pulling the object down. So it will be negative 9.8 meter per second square. All right. And the horizontal, the vertical displacement, we don't know. We could find that out. I'm going to find out that. Like I said, I'm going to find out everything. And the time, we don't know. All right. So let's look at the horizontal bit. The horizontal initial velocity would be what we got here, 72.77 meter per second. All right. And the final horizontal velocity, assuming there is no air resistance, so there's nothing decelerating or accelerating the horizontal velocity, it will remain at 72.77 meter per second. Yeah? You know, year 11, I love year 11 and year 12 physics. You know, it's so not the real world. All right, but, you know, in this case, it will make our question easier. Okay, so therefore, the horizontal acceleration will be 0 meter per second square. And the horizontal displacement, we don't know. And the time, we don't know. Okay. Now, let's use one of the Newton's equation of motion to find out something. Find out the missing piece. All right, let's do time first. All right, one of the equation we can use is V equal U plus AT. Right? We can use that to find out T. And now remember, the T we are finding here would be the same for both horizontal and vertical because, well, this T is literally for vertical. Right? I'm putting all the subscript in here. So this would be the vertical time. But like I said, the main determining factor is the vertical time. So it would be the same for the horizontal one. Right? When it travel to that peak point. Okay, so we're substituting everything we know. So VV is 0. UV is 50.01 pluses, right? AV is negative 9.8 multiplied by time, right? And then what can we do is we can move the negative 9.8 to the other side. Here comes 9.8. T equal to 50.1, and then we divide, right? Divided by 9.8. And we should get roughly 5.1 second. Great, now we've got the T. So the object took approximately 5.1 seconds to reach the peak from the cliff, from on top of the cliff. Okay, so that would be, we can write that in now. Remember that would be the same for the both of them. So that would be 5.1 second, and that would be 5.1 second here. Right. Now, with the time being there now, so we can find out SV and SH, the horizontal displacement and the vertical displacement. All right, let's find out the vertical one first. So SV is equal to UT plus half AT squared. Yeah, that was one of the motion equation. So this is all the AV, and the other one is the same. SH is equal to UH multiplied by T plus half AH T squared. All right, so it's the same. So SV is equal to, now UV is 50.01 multiplied by time, which is 5.1 second, plus half multiplied by AV acceleration, vertical acceleration will be negative 9.8, and then multiplied by 5.1 square. Alright, so we get SV, we get, let me grab a calculator. So 50.01 times 5.1, we get 255.051 pluses 0.5 times negative 9.8 times 5.1 square. We get negative 127.449. Alright, so let's use 255.051 minus that. We get, oh no, there's something wrong on the calculator. It should be plus that answer, because my answer is already negative. If I minus it, it would actually plus it. So 255.051 minus 127.449. So I get 127.602 meter. Alright, because the velocity or the speed is in the unit of meter per second, so the displacement should be in meters. Great, we got one more piece of information. Well, we literally finished it, the vertical bit. Alright, so this is 127.601 meters. Alright, let's look at the SH, the horizontal displacement. So the horizontal displacement is equal to UH would be 72.77 multiplied by 5.1 plus half multiplied by AH. Now AH is 0 in this case, yeah? Because no air resistance, we're ignoring that. And multiplied by 5.1 square. And now the theorem makes it extremely easy, alright? Because the whole bit is gone. This bit is just gone. Alright? So it's literally just distance equal to speed times time. Right? So this is 72.77 times 5.1, giving us 371.127 meters. Right? So this is 371.127 meter. Alright, so we know everything from of the part 1. So what's happening in here? Alright, so let's just jot down a couple of things. So T1 is equal to, I'll use red pen here. We got is 5.1. So therefore, like I said at the beginning, T2, since T1 is symmetric to T2, so that should be 5.1. Right? And we got the total horizontal displacement here is 371.127. So therefore, this bit will be the same. Yeah, because they're symmetric. Remember, guys, they're symmetric. So, yep, that's pretty much it. Right? So that's pretty much. All right. So now we're going to talk about the part 2, which is from the peak down to this point. Remember what I've said right at the beginning. Everything should be symmetric. Part 1 and part 2 should be symmetric. So we don't have to do any calculation to find out what's happening in part 2. All right. So let's go to work it out. Let's just show you what I mean. So what did we say? So at the peak. So we're going to at part 2 now. Oops, should be blue pen. At part 2. At the end of part 2. The end of part 2. Right. So that should be at the peak. So that should be at the end of part 1. Yeah. So at the end of part 2, by what I meant this point here. All right, this point. So we list out, we write the same set of V and H again. So we got U, V, 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 A, V, and S, V, and then T. Here we've got UH, VH, AH, SH, and T. Like I said, because they're symmetric, part 1 and part 2 is symmetric, most of them will be the same. Alright, we know the time will be 5.1 second. From so that means from the peak to the part 2, right, to the end of part 2. Yeah, the horizontal would be the same as before, so it would be what's it? 371.127. 371.127 meter. AH will be always 0 because of we're ignoring air resistance. VH and UH should be always the same because there's nothing accelerating or decelerating the horizontal velocity. 72.77. 72.77. Right. And SV, alright, which is the vertical displacement. Now from the peak back down to this point here. So since we traveled so the SV here, oh, it's a different pen. The SV here is what we calculated, which is 127.602. 127.602 meter. So since it from the top of the cliff, it traveled to the peak, and the peak is 127.602 meters in terms of vertical displacement. When it gets back to that point here, it would have went down 127.602 as well. All right, because everything is symmetric. Right? Alright, so that should be 127.602 meter. Alright? But at this point, AV here, the acceleration the vertical acceleration is no longer negative because now the object is traveling downward, right? From the peak to that point is traveling downward, and which is the same direction as the gravity. So this would be 9.8 meter per second square. All right, and the initial vertical velocity right at the peak, remember, would be 0 because for that moment, the object is not going up anymore. Right at the beginning, right at that split second, and then the final vertical velocity would be like what we said before. It would come back at the same speed, which is 88.3, and if we break that down into the horizontal and vertical component, it would get back what the beginning initial vertical velocity. Well, we will get that back because nothing changed, everything is symmetric. So the final velocity at that point would be 50.01 meter per second. Right? Oh, I'm fucking on all the units here. Alright, units is very important, guys. Good for communication. And yeah, just develop a habit of writing all the units down. Alright? Your teacher will not hate you for that. It will give you, leave a good impression with them. I know it's getting a bit nerdy, isn't it? Okie dokie. Okay, so now we're looking for part 3, which is the final part. So it's when the object from this point, and then till it travel down to the ground and hit the ground, right? But in this case, we are not going to find the thing about the object when it hits the ground, because we know at the end when it hits the ground, things usually just become zeros, right? But in here, we are trying to look for that split second before it hits the ground. We're looking for the information there, okay? So right before the object hit the ground. Alright, so this is from part 2 to part 3. Right? So let's write out our sets again, which is V and then U. All right, so we've got the UV, we've got the VV, and then we've got the AV, we've got the SV, and we got the T. We've got the UH, VH, AH, SH, and T. All right. Okay, so let's start. All right. At the end of part 2, right, to part 3, so from part 2 to part 3, the initial velocity of the object would be the vertical initial velocity, the initial vertical velocity of the object, right? That means right before it leaves part 2, which would be 50.01, right? The final, we don't know. No. See, the tricky bit is here. We don't. Sometimes people say, "Oh, the final is when it hits the ground, is when it becomes zeros." No, because that information doesn't give us that piece of scenario doesn't really help us in this case, because one of the question we have to find the impact it made to the ground, and the impact is right before it hits the ground. We want to know the velocity right before it hits the ground, right? If you put 0 into there, there's no impact, right? So this final vertical velocity is the split second before it hits the ground. That particular vertical velocity is what we want, right? So in this case, we don't know. AV, right? The object is going downward from part 2 to part 3, so it should be positive 9.8 meter per second square. All right. SV, SV we actually know, right? Because from this point, at this point here, right? Since it's symmetric, here the distance, the vertical displacement from this point down to the ground should be 60 meter, right? Just like the cliff, right? So we actually know the vertical displacement from part 2 to part 3, which will be 60 meter, right? And for the time, we don't know. Okay, now let's look at the U side, the horizontal side. No, not the U side. Oh, why am I putting U here? It should be should be horizontal. Oh my god. Good. Right at the beginning, yes. I've just got the last one stuffed up. Okay. So the UH would always be 72.77, right? Because there's no horizontal acceleration or deceleration. Then that would be the same. Even right before it hits the ground, that will remain the same. AH, because AH is 0, no air resistance. Now SH, we don't know, and time, we don't know. Right? Okay, so which one we should find out first? We should always try to aim for the time first. We should try to find the time first, because once we got the time, we can put it into both columns, right? Because the time is the same for both columns. So let's go for times. But this time we don't have the final velocity, so you can't use v equal to u plus at. All right, so we have to use a different one that has the time in it, different motion equation. So in this case, we'll be using s, because we got the s, equal ut plus half at square. Right? So this sv will be sv, it will be uv, and then will be av. All right. So SV, we know that the vertical displacement would be 60 meter, right? And we know the initial vertical velocity would be 50.01. We don't know the time, so we write the time here. Plus half multiplied by, now AV vertical acceleration is positive in this case, so it's 9.8, and then multiplied by t squared. Alright, let's make it look nicer. Let's make the expression look nicer. So it's equal to 50.01 t plus 9.8 divided by 2, or timing half, is 4.9 t squared. Alright, now this looked like a quadratic to me, so I'm going to make it into the quadratic a proper format, which is, which you shouldn't need to write the unit here. Silly me. You only write the unit at the end, right? At the end of the question, when you got the answer. Okay, keep that in mind. So I'm going to move the 6 to the right hand side, and rearrange everything by a bit, making it look nice. And then minus 60. Right, what I'm going to do right now, I'm going to graph it and look at the, I'm going to graph this particular equation, right? And I'm going to look at the x-intercept, which would be our t. We should get two t values because it's a parabola. And well, in the test, you need to use, you can use the graphic calculator solver function, the solver option, and then you can also draw the graph and find the x-intercept as well. All right, but in this case, I'm going to use decimals. All right, now decimals really should pay me for the advertisement. All right, be right back. All right, here's the graph, and I have located the two x-intercept. So we've got two values, right? Like, whenever you solve a quadratic, you should get two values most of the time. We've got a negative. Now, of course, both of them is t values, right? Not x, because I suppose I can put t into decimals as well, but I'm just I like the traditional x and y. All right, so they both are t values. One of them is negative 11.291. Now that doesn't make sense because time doesn't go backward. Well, at least not yet. We can't do that yet. So we will neglect this particular answer because it's not applicable in this particular scenario, and therefore we will choose 1.085. And think about it. If we look at the object, we look at the scenario, right? Right at the end of part 2, right at this point, remember our initial vertical velocity is 50.01, right? And the vertical displacement is only 60 meters, all right? So normally it would, if you in logic, common sense, it would take a bit more than 1 second for it to go down, right? Because all it needs to do is just travel 60 meters downward, and it's already beginning with a speed of velocity of 50.01. And the gravity is accelerating it. So it should take roughly about 1 second, and which would be our answer, right? Which is 1.085, and it makes sense. All right. So whenever you get an answer, quadratic, in a quadratic sense, you have to think about, you have to go back to the scenario and look at the scenario. Which answer makes more sense? All right, and then most likely, physics is the real world, is how things work. So it should be logical. All right, the answer should be logical. So your logical deduction should always give you the better answer. All right, so that's why we use 1.085 in this case. So now we know. Therefore, t is equal to approximately 1.085 seconds. Cool, we got t, we can put that in here. 1.085 seconds. And remember, they're the same for both of them, so we can put that in here as well. 1.085 seconds. Cool. And with the t, we can find out the horizontal displacement, right? SH. So let's do that. So SH is equal to, use the same formula, U multiplied by UT plus half AT squared. Now this is SH, that would be UH, and that would be AH, right? So horizontal displacement is equal to, UH would be 72.77 multiplied by 1.085 plus half multiplied by AH would be 0, no air resistance, and multiplied by 1.085 square. And then we know that this part is gone because the 0 is in there. So like I said, it's just distance equal to times speed times time. So what would that be? So 72.77 times 1.085. So we get 78.95545. Cool, meters. All right, we got that bit, and we got 78.95545. Yeah, cool. And the last piece of information missing is just the VV, the final vertical velocity, right before it hits the ground, okay? Now, having the time available to us now, we should be able to find the V. So we can use the equation, motion equation, V equal to U plus AT, right? So there would be VV, UV, and AV, okay? So VV, vertical final velocity, would be UV, which would be 50.01 plus 9.8. In this case, gravity is going down, so it's positive, the object is going down. And multiplied by our time we found, which is 1.085. Alright, so VV should be equal to 50.01 plus 9.8 times 1.085. That gives us 60.643 meter per second. Cool. Last piece of missing information. We can put it back in here. So that we got 60.643 meter per second. Right. Now we can find the final velocity. We're going to put back the horizontal component and the vertical component together, add them, and find the resultant vector, which will be our impact speed. All right. So let's draw that. Our vertical is going downward, which would be 60.643. And then our horizontal would be a bit longer than that, which would be 72. 72.77, and we're trying to find the resultant, which would be that, the hypotenuse, and preferably the angle as well, because we need well, the impact. You need impact is also a factor, and you need a direction, right? So we can use the Pythagoras theorem to find out the hypotenuse, which will be c squared, which will be c. All right. So c is equal to square root of 60.643 square plus 72.77 square, right? And if we calculate that, put it in there, we get 60.643 square plus 72.77 square root the answer, giving us 94.726 726 meter per second. All right, so that's the resultant velocity, the impact velocity. Cool. And now to find the angle, we can use tan, right? So tan theta is equal to 72.77 divided by 60.643. So theta is equal to inverse tan bracket 72.77 over 60.643. Theta is equal to 72.77 divided by 60.643 inverse tan. Answer equals 50.19. Let's just go 50.2. So we know now that is 50.2. So therefore, this particular angle here to the horizontal, from the horizon is 39.8. Right? So now we can answer all those questions. All right. So let me just draw the last part there. So we're just looking at the angle that we just found is this angle, which is 39.2 theta. Yep. Okay. So how far away from the base of the cliff will the object land? Oh well. So we're adding all the SH, the horizontal displacement, right? So the answer would be 371.127 plus 371.127 plus the last bit, the last horizontal displacement was 78.95545. 78.9 something. 95545. Oops, 95545. So that gives us 371.127 times 2 plus 78.95545, giving us 821.20945 meter. Good. So now we can answer the question. Remember, if the question asks you with a sentence, you have to answer back as a sentence. Okay, so just giving them this is not a perfect communication. Okay, so the object, therefore, the object will land 821.20945 meters away from the base of the cliff. Cool, perfect answer. Yeah. Second one, for how long did the object travel in the air? Well, that's easy. We just add all the times together, right? So we got 5.1, 5.1, and the last bit is 1.1085, if I remember correctly. So that would just go 5.1 plus 5.1 plus 1.085. So that would give us 11.285 seconds. So let's answer in the sentence as well. The object traveled in the air for approximately, because we did round things up every now and then, 1.285 seconds. Cool, perfect answer, love it. And then they say, what is the final impact of the object to the ground? Well, we already got it, right? We already got the thing. We've got a resultant velocity and an angle as well. So what's the final impact? It would be 90 something, right? What's it? Forgot. It was 94.726. 94.726 at 39. Is it 39.8? Yeah, 39.8 degree below horizontal. All right, so we can just answer here. The impact is 94.726 meter per second, I forgot, at 39.8 degree below horizontal. So what I meant by that is because we're assuming this is the horizontal, and the impact would be that, all right, which is 39.2. All right. I mean, look, the angle bit, you can use whichever reference point you want. You can use the what I use here is the reference point here, but you can also use the reference point here as well. So it's up to you. Okay, so that's it. Wow, that's 50 minutes, nearly an hour. Whew, I've been talking for an hour. All right, so this is how you do this type of question, and this is, I mean, as tough as it can get, right? You know, more or less. And hopefully after watching this particular video, it makes you, understand more about projectile motion and how to calculate different parts of when the different parts of the object, traveling to some different places and stuff. So hopefully this helped, and we'll see you next time.